So today we are going to start with the chemical properties of carboxylic acid. We are starting with the chemical properties of carboxylic acid. And the first chemical property of carboxylic acid that we are discussing today is nothing but your electrophilic substitution reaction in aromatic carboxylic acid like benzoic acid. So we are discussing first of all electrophilic substitution reaction in benzoic acid. So first of all you are going to see in benzoic acid which are the positions where electrophile is going to attack. For that we need to draw the resonating structure of the benzoic acid. The group is going to show minus R effect. It's an electron withdrawing group, and you do know when the electron withdrawing group is there on the benzene ring, the orthopara positions becomes positive center, so electrophile is going to attack at the meta position. So this is how the electrons are going to move like this. The group is electron withdrawing, it shows minus R effect, electron withdrawing group, the carboxylic group. So like this the electrons are going to move. You can see the ortho and para positions, they are getting a positive charge, and since electron withdrawing group is there on the benzene ring, it is going to deactivate benzene ring towards the electrophilic substitution reaction. So these are the 5 resonating structures we have. We'll draw the hybrid. This is the resonance hybrid, average of all the structures. The bonds involved resonance, they will be having a partial double bond character. Positive, 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 small negative charge. So if electrophile attacks on the benzene ring in the case of benzoic acid, only position where it can attack is the meta position, which is not having a positive charge. The third position is called meta position. So we write that in benzoic acid, due to resonance, the orthopara positions act as a positive center. So the electrophile attacks on benzoic acid at meta position, in benzoic acid at meta position. Secondly, in benzoic acid, since COH group shows minus R effect, COH group shows minus R effect, shows minus R effect, it withdraw electron from the benzene ring, withdraw electron from the benzene ring. On the benzene ring, electron density will become more, so it deactivates the benzene ring. It deactivates the benzene ring towards electrophilic substitution reaction. Towards electrophilic substitution reaction. The rate of the reaction is going to be very slow. So the group is a not meta directing, and it is a deactivating group towards electrophilic substitution reaction. Now let us see the examples of electrophilic substitution reaction. You know all the halogenation, nitration, sulfonation, and the Fieldcraft reaction. So we are discussing first of all halogenation. All of them are going to happen at the meta position. So halogenation reaction. So we have benzoic acid, we do halogenation, Cl2 FeCl3, we'll get metachloro product, metachlorobenzoic acid. We can do bromination also. And let's do the next one called nitration. NO2 group will attach again at the meta position. So we have benzoic acid. Let's do nitration. Concentrated HNO3, concentrated H2SO4. We will get metanitrobenzoic acid. And the rate of the reactions are going to be very slow because the benzene ring is highly deactivated. Next one is sulfonation. The SO3H group will attach at the meta position. How do we do sulfonation? We reacted with concentrated sulfuric acid. So we react with concentrated H2SO4. The group that attaches at the meta position is SO3H. So we get this product. Now if you try to do Friedel-Crafts reaction with benzoic acid, you will find the reaction will not take place. The benzoic acid doesn't undergo Friedel-Crafts reaction. Neither it undergoes alkylation nor it undergoes acylation. The benzoic acid doesn't undergo Friedel-Crafts reaction. So if you have benzoic acid, you reacted with alkyl halide in the presence of anhydrous AlCl3, or you react with acid chloride, react with anhydrous AlCl3. In both the cases, alkylation or acylation, answer will be no reaction. And definitely the question comes, why benzoic acid does not undergo Friedel-Crafts reaction? The reason is very simple. When you react benzoic acid with alkyl halide and anhydrous AlCl3, benzoic acid is going to react with AlCl3. How? You can see benzoic acid reacts with the Lewis acid, that is anhydrous AlCl3, which is supposed to be a catalyst. So benzoic acid is there, it has an oxygen with a lone pair of electron. This lone pair of electron can be accepted by the catalyst, that is AlCl3. So instead of benzoic acid reacting with alkyl halide or acyl halide, it reacts with anhydrous AlCl3. This is a Lewis base, this is a Lewis acid. So benzoic acid doesn't undergo Friedel-Crafts alkylation or acylation. So because it reacts with anhydrous AlCl3, that is a catalyst. Like it happened in the case of aniline also. Aniline, for the same reason, was not undergoing Friedel-Crafts reaction. Now whatever we have studied so far, the electrophilic substitution reaction of benzoic acid, we can discuss two important questions given in the NCERT. The first question is convert benzene into metanitrobenzoic acid. That is quite easy. Though the second one is also easy, we have to convert benzene into para-nitrobenzoic acid. Para-nitrobenzoic acid. So we have the benzene. First of all, let's make it benzoic acid. First of all, we convert it into toluene by doing Friedel-Crafts reaction. We are going to get toluene, which can be oxidized into benzoic acid. Remember, I told you can oxidize with KMnO4 in basic medium, followed by acidification, the second step. You can get the benzoic acid. Toluene gets oxidized to benzoic acid, and you can do nitration to get the meta product. You can do nitration, conc HNO3. You can react with concentrated sulfuric acid. You are going to get metanitrobenzoic acid. If you want to get para, what you do? You take the benzene, convert into toluene, and before oxidation do nitration. CH3 group is an orthoparadactyl group. It's an electron donating group. So we make toluene, we do nitration, concentrated HNO3, concentrated H2SO4, we get para-nitrotoluene, and we do oxidation. After we get a para product, we can oxidize again in the basic medium, followed by acidification. You will get para-nitrobenzoic acid. So this is how we can do these following conversion. So this was the first property of the carboxylic acid, that is electrophilic substitution reaction happening in the case of benzoic acid. Let us see few more chemical properties. The second one, which already we have discussed in the preparation of your alcohol. When you reduce the carboxylic acid, it gives you corresponding primary alcohol. The reducing agent we can use is lithium aluminum hydride, followed by reaction with water. What is going to happen? Oxygen removed and you put 2 hydrogen. So we get the corresponding primary alcohol. If you don't like lithium aluminum hydride, even you can use B2H6. You can use diborane as a reducing agent. Both of them are going to reduce carboxylic acid into primary alcohol. For example, you've got propanoic acid. If you reduce it, you're going to get propanol. LLH4 you put, followed by water, you're going to get the formation of propanol. So we already discussed carboxylic acid on reduction gives you the corresponding primary alcohol. Now the third chemical property, we can convert carboxylic acid into its derivatives. You know what are acid derivatives? Derived from acid, we can make acid chloride, we can make amide, we can make anhydride, we can make ester, all starting from carboxylic acid. We can convert carboxylic acid into its acid derivative. Like we have done, if you want to convert an acid derivative into carboxylic acid, we just do hydrolysis. So the first step, if you react with SOCl2, if you don't like SOCl2, you can go for HCl. You don't like HCl, you can go for PCl3. You don't like PCl3, you can go for PCl5. In all of them, OH will be replaced by Cl. You get a formation of an acid derivative called acid chloride. If you heat carboxylic acid with ammonia strongly, you will get an acid amide. This reaction we have done even in the case of amines. If you react acid with an alcohol in the presence of sulfuric acid as a catalyst, OH replaced by OR, you get a sweet smelling compound called ester. And finally, if you take 2 carboxylic acid, remove water between them, you can use the dehydrating agent P2O5. Water is removed, OH will go from here, H will go from here, and you will get the formation of a compound called acid anhydride. So you can convert carboxylic acid into the corresponding acid derivative. These are called acid chlorides. Already you know, these are called acid amides. These are your sweet smelling compound called esters. These are nothing but the acid derivatives called as nothing but anhydride. So you can convert carboxylic acid into its corresponding acid derivative. If you want to convert back, you put water. All of them will convert into nothing but carboxylic acid. Now we are going to discuss one of the reactions we have done in your 11th class. That is a step down reaction. That is called decarboxylation by soda lime. This we have done in 11th class for the preparation of alkene. Decarboxylation, that is removal of carbon dioxide with soda lime. We are going to use soda lime. Soda lime, if you remember, was a mixture of NaOH, calcium oxide in the ratio of 3:1. Decarboxylation means removal of carbon dioxide. It's a step down reaction. In this, carboxylic acid will be converted into alkene with 1 carbon less. Carboxylic acid converted into alkene with 1 carbon less. 1 carbon will become less in number. In this, what we do, we take carboxylic acid, we make a sodium salt, react with NaOH, H replaced by Na, you get a sodium salt of carboxylic acid. The sodium salt of carboxylic acid, if you heat with soda lime, NaOH plus Cu in the ratio of 3:1, the carbon dioxide is lost and you will get an alkane with one carbon less. It is a step down reaction. You can decrease the carbon atom by unity. For example, we need to convert benzoic acid, 7 carbon containing compound, we want to make it benzene. So we take benzoic acid, you make a sodium salt, NaOH, you get sodium benzoate, sodium salt of benzoic acid, heat it with soda lime, NaOH, calcium oxide in the ratio of 3:1, you will get nothing but the benzene. This is going to go off. So this is a very important step down reaction. Before we go on further, let's do some step up and step down reaction. Very interesting, not going to come in the board examination, but good enough to practice the equations or the reactions we have done so far. So let's say, suppose somebody asks you to convert propanoic acid, the acid with 3 carbon. We want to make it into an acid with 2 carbon. We want to make it into ethanoic acid. Propanoic acid has to be converted into ethanoic acid. Step down reaction. We start with propanoic acid. Since we have to decrease the carbon by unity, we react with NaOH. You're going to get a sodium salt. Heat it with soda lime. Soda lime is NaOH. Calcium oxide, 3:1. Heat it. CO2 gone. You will get ethane. Now you don't want ethane, you want ethanoic acid, no problem. Do chlorination. Convert into an alcohol. You know how? By reacting with aqueous, NaOH. Once you get an alcohol, you do know alcohol can get oxidized to carboxylic acid. So you can use KMnO4 in the basic medium, followed by acidification, and you will get ethanoic acid. So it's a 6-step conversion, which is not going to ask in the exam, but good for the question. So it's a step down reaction, propanoic acid into ethanoic acid. Now let's do the reverse. Let's say we have to do step up. We have to convert ethanoic acid. We have to increase the carbon by unity into propanoic acid. Ethanoic acid into propanoic acid. So in this we use that KCN wala method. So ethanoic acid, just now did, if you do reduction, you're going to get an alcohol, primary alcohol. Then you put a halogen, best method, SOCl2. You will get CH3CH2Cl. Increase one carbon, you put KCN. Cl will be replaced by Cn. And how to convert Cn into an acid, you know, complete hydrolysis, dilute HCl in so many times, and you get back the propanoic acid. So the world is round. You can go from propanoic acid to ethanoic acid, and you can convert ethanoic acid back to propanoic acid. Step down, step up. Let us practice some more step down, step up reactions. Let us come to alcohols. Let's say we have to convert ethanol into methanol, that is the step down reaction, and the vice versa, that is you want to convert methanol into ethanol, that is the step up reaction. So how to convert the ethanol into methanol? We take ethanol. So step downing, we want an acid, so we oxidize it first of all into an acid. You will get ethanoic acid. Since you have to decrease the carbon by unity, we'll make a sodium salt, and subject to decarboxylation by soda lime. So put soda lime, NaOH plus CO in the ratio of 3:1, heat it, you will get methane. I don't want methane, I want methanol, no problem. Chlorination, CH3Cl, and then you react it with aqueous NaOH. The Cl will be replaced by OH. Now we have to do step up, increase carbon by unity. You can go by a KCN method by which you increase the carbon by unity. So same, SOCl2, you put halogen, step up, you put KCN, then you put dilute HCl, and once you get an acid, how to make it alcohol? Reduce it, LiLH4, water, you will get an alcohol. So you can step down, step up even in the case of alcohol. Now let's come to amines. Again, step up, step down. Let us say you have to convert ethanamine. I want to make it into methanamine. Again, step down. Now we want to step up. Let's say the reverse. I want to convert methanamine. I want to convert it back to ethanamine. The world is round. Now if you want to step down, we want an acid. For acid, we want an alcohol. We have done in amine that if you take aliphatic amine and you react with nitrous acid, HNO2, or you can remember like this, HONO means the same thing. NH2 will be replaced by OH. Once you get an alcohol, you can make it into acid. You know how? By oxidation, KMNO4, KOH, followed by acidification. Once you get an acid, you can step down using decarboxylation, make a sodium salt, heat it with soda lime by reacting with NaOH, CO in the ratio of 3:1, heat it, you will get methane. Then how to make it ammonia? Chlorination, CH3Cl. And how to make it amine? You can react with ammonia, excess NaOH, the Cl is replaced by nothing but NH2. So 6-step conversion, good for the practice, nobody is going to ask in the exam. Now if you want to do step up, methanamine into methanamine, again you put HONO. You know what happens in HONO? NH2 will be replaced by OH. Step up, KCN, for that we need a halogen, so CH3Cl, then you put KCN. We have CH3CN. How to make it amine? Reduce it. Lithium aluminum hydride. You get ethanamine. So we've done acid. How do we do step up, step down? We've done alcohol. How do we do step up, step down? We've done amines. How do we do step up, step down? Enough of practice. So whenever you want to do step down, you can go for two reactions. One is decarboxylation. One we have done in amines. It was Hoffman bromamide reaction. If you remember, if you're revising the classes. And step up, it is by KCN, by using Grignard reagent and all that blah 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 blah. So this was the chemical property of carboxylic acid, that is decarboxylation. Now we are going to discuss the last one for the today, that is called HVZ reaction. The full form is nothing but Hell-Volhard-Zelensky reaction. Hell-Volhard-Zelensky reaction. Hell-Volhard-Zelensky reaction. In this what happens is alpha halogenation, alpha halogenation of carboxylic acid. You can put a halogen in the alpha position in carboxylic acid. Suppose we have a carboxylic acid. This is the functional group. This carbon adjacent to the functional group is called alpha carbon. Alpha carbon is next to functional group. This is functional group, the next carbon is called alpha carbon. So when you react with chlorine or bromine in the presence of red phosphorus, one of the hydrogen will be replaced by halogen. You have a alpha halogenation that is going to happen. You get an alpha halogenated product, and of course plus HX. Depend, you can put CLBr, it's your wish. How do I use this in conversion? Like suppose if they ask you to do this conversion given in NCERT, they ask you to convert propanoic acid into propenoic acid. I want a double bond. So what I can do it in two steps. I can have propanoic acid. I do alpha halogenation, Cl2, red phosphorus. I will get 2-chloropropanoic acid. How to put a double bond? You remember the reaction called Bevada KOH, alcoholic KOH, dehydrohalogenation. Cl and H will be removed and you will have a double bond and you will get propanoic acid. Another one, suppose you want to convert propanoic acid into lactic acid. Hopefully you would have forgotten what is lactic acid. Lactic acid was nothing but 3-hydroxy propanoic acid. So how to go about it? An optical active compound. So propanoic acid, first of all, to HVZ reaction, put a halogen at the second position, and now how to put OH? Put aqueous NaOH, and the Cl will be replaced by nothing but OH. So this was the next reaction, and the last reaction for the day, that is called Hell-Volhard-Zelinsky reaction. We are left with one more chemical property of carboxylic acid, that is its acidic nature, which is quite a big property, which today we can't do it. We'll do it tomorrow because we'll start tomorrow and end tomorrow. In the meantime, we have got some time left, so I can tell you a chemical test of carboxylic acid. Though it is the last topic, but we are doing today because we have time left, so we can wind up at least this topic today before closing down the class. How do we chemically test the presence of carboxylic acid? The test is very simple. We'll do it in the lab also when the school reopens. You take any carboxylic acid. In this, you put either sodium bicarbonate or you put sodium carbonate. You will get brisk effervescence. You get a sodium salt of carbon dioxide, and the brisk effervescence is due to the evolution of the carbon dioxide gas. How do we use this particular chemical test? Of course, you can do esterification also as a test. Acid, if you put any alcohol, heat it, you get a sweet smelling compound. So suppose they ask you in the exam how to chemically differentiate between benzoic acid, and let's say we have to differentiate it from phenol. Chemical test to differentiate benzoic acid or phenol. So what you can do, you can take benzoic acid, you can put sodium bicarbonate or sodium carbonate. You will get a sodium salt of benzoic acid, CONA. And which gas will be evolved? CO2. There will be brisk effervescence due to the evolution of carbon dioxide gas. In this, if you will put sodium bicarbonate, answer will be no CO2 evolved, or no reaction, or no brisk effervescence. So this is a test, that is to differentiate carboxylic acid from any other compound. So we have discussed some of the chemical properties of carboxylic acid today. Tomorrow, the last class of carboxylic acid, we are going to discuss its acidic nature. As the name suggests, carboxylic acid are acidic in nature. They do turn blue litmus red. Thank you. Take care. Bye.